Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at multiplication and division of complex numbers. And in this particular video, I'm going to emphasize on the concept of multiplication. And therefore, this is going to be, of course, entailing the previous two concepts which we have learned in terms of representation of course, point on Cartesian coordinate system in terms of polar forms. And also we're going to see that the application of functions of compound angles as well is going to be coming into play in this specific discussion. And therefore, in our evaluation, we are going to be involving, of course, a representation of complex numbers which are going to be given in terms of polar coordinates. And this is going to be given in terms of r the cosine over theta, which we can give as such, plus, of course, we're going to have I the sine over theta. Now, assume that we understand this specific representation from our previous discussion on the concept of course, the representation of a complex number, which we had given in terms of x, which is going to be the real axis or the real component plus the imaginary component given as such. So basically, we're going to have this specific representation done using this specific format of a polar form, and that's going to be assisting us in trying to evaluate the specific of course, equations which we are going to come across for the concept of course, complex numbers. Now, suppose we have a complex number represented as a phase of z and w, and this can be given in terms of r, the cosine over phi, and plus this I, or plus the imaginary unit, and then the sine over phi given as such. So we can find a multiplication of these two specific components of the complex numbers, which can be given in terms of the phase of z and w equivalent to. So we are going to have this one given in this specific form, whereby I'm just going to be maintaining this specific, of course, common points for r and of course capital R and small r, which are going to be assisting us with the distance section. So I just mentioned that if we consider this specific Cartesian component, then we're going to have this one represented as r, and therefore that's going to be forming our x and y. So in this case, these have been represented in polar coordinates, and this is going to be forming our r in this particular case. And therefore, we shall have this one given in terms of r into the cosine over theta plus I the sine over theta. And then we're going to have this r into the cosine over phi plus I, or imaginary component of the sine over theta. So this can be evaluated by having these two specific, of course, components given as r, capital R, and then we are going to have these other factors given in terms of I, the sine over theta, into the cosine over. So this is going to be the cosine over phi plus I, the sine over phi given as such. So for us to do this specific multiplication, we're going to have this still given in terms of r, capital R, small r, and then we're going to have this as the cosine over theta, cosine over phi, plus I, the cosine over theta, the sine over phi, and then we're going to have this one plus. So we're going to take the second, of course, the second part of this specific first factor, which is going to be I, the sine over theta, and then the cosine over phi, and then plus the last term, which we're going to have still for the imaginary component, the sine over theta, and then I, or imaginary component, the sine over phi given as such. So from our previous discussion on the concept of angles, which we had said, so we had basically mentioned in one of our videos that if we have this specific component square, and that's going to be giving us, of course, what we refer to as -1, which is basically the root of -1 times the root of -1, which is going to be given as such. So for the first, second term, third term, and the fourth term, we can see that for the fourth term, it's going to be consisting of such a kind of an evaluation where we are going to be required to find the square of that one. So therefore, we can do an rearrangement whereby we're going to have r given in terms of the cosine over theta, cosine over phi, minus, so this minus sign is going to be a result of these two specific components. So I'm rearranging this specific equation in a sense that we are going to have this imaginary component, the only one factor for the imaginary component being reserved for the second and the third terms, and then we're going to have the fourth term which is going to be evaluated, and the imaginary component is going to be disappearing due to this specific factor, and we're going to have a coefficient of a -1. And therefore, this implies that we're going to have this one given in terms of this sine over theta, this sine over phi given as such. And this is going to be plus this particular component of I into the cosine over theta, the sine over phi, plus the sine over theta, cosine over phi. So in this case, if we look at this specific section for the first case which we have seen, so this is going to be forming one of the reference for the previous discussion which we had basically on the concept of the compound angles for the cosine, which we said that if we have an angle, a compound angles for the A and B given as such, so this can be given as the cosine over A cosine over B minus the sine over A sine of B given as such. And this is going to be analogous to these specific results we are obtaining for the first and the second term. And this basically can be substituted for the cosine of course, the sum of theta plus phi in this specific case. And therefore, this is going to be giving us, of course, a result which can be given in terms of this r into the cosine over theta minus phi. So if we come across, so this is going to be addition basically. So this is going to be the sum of the two angles for the compound angles of theta and phi given as such. And this is going to be resulting from this specific section of the first and second term, which I have said. Now we shall have this one, of course, with I, which is going to be given as the cosine of this specific theta, the sine of phi, and the sine of theta cosine of phi. Now for the second section as well, this is going to be also forming a specific, of course, sum of the sine function for the compound angles, which we said in case we have the sine over theta plus phi, and therefore the sine over these two specific angles is going to be giving us a result of this specific form which I've given on the board. And therefore we are going to be giving this specific representation for this section which can be identified for the compound angles given as such. So we shall have this one given as our imaginary unit given as such, and we're going to have the sine of theta plus phi given as such. And this is going to be forming what we refer to as a representation for the, of course, this specific aspect of the multiplication of the two complex numbers which we have just had on the board for this phase of W, or phasor of Z and W given as such. So in case we come across this specific kind of evaluation, so kindly remember that there are specific formula which we are going to borrow from our previous discussion on the concept of functions of compound angles given as such. And in our subsequent videos, perhaps we are going to come on additional range of this specific formula or results of compound angles which we are going to be required to apply appropriately. So catch us in our next video as we're going to look at the concept of division. And this is going to be assisting us try to find a contrast between our relationship between this specific aspect of division and multiplication in that specific order. So kindly check our description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell, subscribe, and of course invite more members so that we can form a large community of members discussing various topics in science and mathematics. So that is it for now, guys. Bye. God bless you. Catch us in our next video.